Welcome to our video lesson of finding prime factorization of a composite number. You're going to take today's note on page 19, where we glued the tree foldable from yesterday. Alright, let's get started. First, can you write down our title, Factor Tree, on the outside of our foldable? Then, you're going to write the subtitle of Using a Factor Tree for Prime Factorization. Before we can continue, you need to know what prime factorization is. Prime factorization is to write a number as a product of prime numbers. Remember, product means multiplication. So to write a number as a whole bunch of prime numbers multiplied together. I'm going to move on to the next slide. If you need to, pause the video now so that you can get all this stuff copied down on the outside of your foldable. Alright, I need you to write down these steps. Do not write them in your foldable. Not in your foldable. Write them somewhere else on that page, but not inside your foldable. The first step for finding the prime factorization of a number is to write down two factors that multiply to give your number, or your top number. If one of the factors is prime, then you're going to circle it. If the factor is not prime, continue down that branch of the tree until you reach a prime number. Write all of the circled numbers together from least to greatest to give the prime factorization. Don't worry if you don't understand the steps right now. All I need you to do is copy them down so that you have them for later. We're going to do some examples to help you understand. So pause the video now until you get this copied down. You're not copying it inside your foldable. Alright, now this you're going to do inside your foldable. So lift it up and put this on the inside. Alright, we're going to make a factor tree for the number 48 to find the prime factorization of this number, or a whole bunch of prime numbers that when we multiply them together give us 48. When I see 48, I always think in my head that it's divisible by 2. Remember our divisibility rules? 48 ends in a prime number. Sorry, not a prime, even number. So I know it can be divided by 2. So I'm going to put 2 as my first factor. Another factor, what times 2 gives 48? So you can divide 48 by 2. 2 goes into 4 twice. 2 times 2 is 4. And 4 minus 4 gives 0. Bring down that 8. 2 goes into 8 4 times. So our other factor would be 24. We're going to write those two factors under two lines because if you multiplied them together, they would give us back the 48. Okay, we've done step 1. Step 2 is if one of the factors is prime, we need to circle it. Is 2 prime? Yes, 2 is a prime number, so I'm going to circle that. Now is 24 prime or composite? It's not prime, so it must be a composite number. Alright, let's go on to step 3 then. If the factor is not prime, continue down that branch of the tree until you reach a prime number. Alright, we're going to continue down this branch of the tree. What two factors, when I multiply them together, give us 24? Well, I always think of 3 and 8, because 3 times 8 is 24. Now, is 3 prime? Yes, 3 is a prime number, so I'm going to circle it. Is 8 prime? No, 8's not prime, so I'm going to continue down that branch of the tree. 8, what two numbers can multiply together to give us 8? 2 and 4. I'm going to circle 2 because it's a prime number. Now I continue down with 4. What two numbers can multiply together to give me 4? Well, there's 2 and 2. They're both prime, so I'm going to circle them both. Now I've come to the end because all of my branches are closed with our nice prime numbers at the end. Now we're going to write all of the circled numbers together from least to greatest to give the prime factorization. Remember, factorization is multiplying. So down here I'm going to write that 48 is equal to, and we have to put them in order from least to greatest. So our smallest numbers are the 2s. So I'm going to write 2 times 2 times 2 times 2 times 3. And that is the prime factorization of 48. Now I wrote 4 2's here. Looking down here, why did I write 4 2's? I wrote 4 2's because there's 1, 2, 3, 4 2's on the end of my branches. I wrote the 1 3 because there's 1 3 here at the end of my branch. We're going to do another example. This example you're going to write down somewhere outside of your foldable. So maybe by where you wrote the steps, anywhere on that same page that's not in your foldable. But not foldable. Alright, the first step is to find two factors that when multiplied together will give us 147. Okay, in this situation I'm going to need our divisibility rules. So, is 147 divisible by 2? No, it's not, because it doesn't end in a 2, or an even number. Not just a 2, an even number. Now, is it divisible by 3? We can check by adding the digits together. So what's 1 plus 4 plus 7? Well, 1 plus 4 is 5, and 5 plus 7 gives us 12. And 12 is divisible by 3. So that means that 147 must be divisible by 3 as well. So down here I'm going to put a 12 and a 3. Sorry. That is not correct. Don't do that. I know that it must be divisible by 3, so I'm going to divide 147 by 3 to figure out what other number I will put down here with our 3. Well, 3 can't go into 1, but 3 can go into 14 4 times, and 4 times 3 gives 12. Then I subtract 14 minus 12 gives me 2, and I bring down that 7. 3 goes into 27 9 times, and 9 times 3 is 27. Subtract the 2 and get 0. So the other number, the other factor that belongs with my 3 is this 49. So I'm going to write the 49 right here. Then I see if they're prime. Is 3 a prime number? Yes, it is, so I'm going to circle it. Is 49 a prime number? 49 is not a prime number, so I'm going to continue down this branch. I know that 49 is divisible by 7. And I know that 7 times 7 will give me 49. So those are my next two branches on this tree. Is 7 a prime number? Yes, it is. So I'm going to circle it. I get to circle both of them because they're both 7s and I know they're prime. Now the end of our tree has all circles, so that means I'm done with my prime factorization. Now I just need to write it out. 147 is equal to 3 times 7 times 7. I wrote the 3 first because it is my smallest prime number. Then I wrote the 2 7s because they're my other two prime factors. And I wrote 2 of them because there's 2 in my problem. Those are all my examples. Now it's time for you to practice this. You are going to find the prime factorization of these 5 numbers. You need to show all of your work on page 20. I need to see everything written out there, even your division if you need to do it. When you are finished, you can do one of 2 things. First, you can move on to our greatest common factor lesson, which you have the video sheet for and is posted under Monday's class. Or you can work on your key terms using your textbook or using your cell phone. It's not an option not to do anything. You need to do one of those 2 things. That's all for now, and I'll talk to you later.